Let's now look at the normal distribution and standard deviations. Our objective: given a normal distribution, find data values at a specified standard deviation from the mean. Okay, what do we come in knowing? Well, we know what a normal distribution is: a graphical display of normal data in which the data tend to cluster around a central value. We focus on the mean, with fewer and fewer values occurring as you move away from the mean. Okay, so here's the mean. And we can see that in a normal distribution, a bell curve, most of the data is very close into the mean. We learned last time that it's 68% is in this between +1 and -1 standard deviations. But the data really tends to cluster. In other words, most things that are normal have attributes where you're close to the mean. Okay. Now we also got a standard deviation, a measure of how spread out the data are. And we saw that these tick marks here, we now know what they represent. This is the mean. This data location here, data point, is 1 standard deviation above the mean. The plus means above. This is 2 standard deviations above the mean. This is 3 standard deviations above the mean. And again, we could go 4, 5, etc. But there's very little area under the curve as this thing tends to go further and further away from the mean. Similarly, this is 1 standard deviation below the mean, the negative representing below. This is 2 standard deviations below the mean and 3 standard deviations below the mean. And I'll go ahead and mark this with, these are our standard deviations. Okay, so let's use this to find some data values. So I've mentioned before, maybe a couple times, that adult heights are normal. Okay, there's a mean of all male heights of what I have here, and the vast majority of men tend to be pretty close to that mean. There are very few people who are really, really tall, and there are very, very few people who are really, really short. Okay, so example 1 here, male adult heights are approximately normally distributed, and that's key. We have to be told that things are normally distributed in order to use the normal distribution, with a mean of 70 inches and a standard deviation of 4 inches. Find the height that is A, 2 standard deviations above the mean, B, 3 standard deviations above the mean. Okay, well, here's my normal distribution. It's always nice to see a sketch to see what's going on. This is the mean. This is 1 standard deviation above. This is 2 standard deviations above. And this is 3 standard deviations above. Make up a little bit higher here. And then we'll go below the mean. This is 1 standard deviation below. This is 2 standard deviations below. And this is 3 standard deviations below. And the reason we stop at 3, as we saw in a previous video, that covers 99% approximately of all male adult heights in this case. So we've got pretty much everybody is between here and here. Now, yes, there are very few people in this wing down here that are taller, and there are very few people, men in this wing down here that are shorter. We've captured 99.7 within 3 standard deviations below and 3 standard deviations above. So now we know the data. We know our mean is 70 inches. What is that? 5'10", I think. And we have a standard deviation of 4 inches. So +1 is 74 inches. +2 is 78 inches. +3 is 82 inches. And go down 1, and we're at 66 inches. Go down 2 standard deviations, subtract 4, and I wrote a 4, that's a mistake. Subtract 4, get to 62 inches. and subtract 4 again, and we get to 58 inches. So 99.7% of men are between, let's see, 60 inches is 5 feet. So this is 4'10", and my goodness, I guess that's 7'10", if I do that right. And that 6'10", excuse me. You know, so that gives us 99.7% of our men. Okay, how many find the height that is 2 standard deviations above? Okay, so we want to be plus 2 standard deviations. Okay, here's the mean. Plus 1, we added 4. Plus 2, we added 4 again. 2 standard deviations above the mean is someone who is 78 inches tall, which is 6'6". Another way to do that mathematically, without the chart, 70 plus 2 times 4, which is 1 standard deviation, is going to give us 78. Okay, letter B, find the height that is 3 standard deviations below the mean. So we want to be minus 3 standard deviations, the minus meaning below. We come down to our chart and we see that's 58 inches. The height that is 3 standard deviations below the mean is 58 inches. And again, I think that's 4'10". Okay, mathematically, we're going to do 70. We're going to minus 3. So the minus 3 standard deviations, every standard deviation is 4 inches, and we come up with 58. Let's do the same thing for women. Okay, so let me change papers. Or let's do a similar thing for women, if you will. Okay, example number 2. Female adult heights are approximately normally distributed with a mean of 65. So in general, the average height for women is 5 inches shorter than the average height for men, and a standard deviation of 3.5 inches. So that's the data is a little bit closer to one another. The standard deviation is smaller than that for men, so our normal curve is a little bit tighter, a little bit taller, a little bit closer in. Okay? So let's go ahead and put this on our graph here so that we can answer questions A and B. So again, here's the mean. This is 1 standard deviation above, 2 above, and 3 above. Here's 1 below, 2 below, and 3 below. And now let's put the data underneath this generic labeling. A mean of 65, so this is 65 inches. If we add 3.5 and we increase it by 1 standard deviation, this is going to be 68.5 inches. Go up by 3.5 inches, 1 standard deviation. If we add up 2 standard deviations, I can add 1 to this one, and I'm at 72 inches. Add again 3.5, and I'm at 75.5 inches. Let's do it in the shorter direction. 65, take away 1 standard deviation of 3.5 is 61.5 inches. Take away another standard deviation of 3.5 and we're at 58 inches. And then take away a third standard deviation of 3.5 and we're at 54.5 inches. Okay, so remembering our 68, 95, 99% rule, 68% of women, female adults, fall between 61.5 inches and 68.5 inches. So this is 5'1.5", and this is 5'8.5", with a mean of 5'5". Okay, so let's answer these 2 questions. Letter A, find the height that is 3 standard deviations above. Okay, well, it's on our chart. 1, 2, 3, the positive 3 means above, and that height is 75.5 inches, which is 6'3.5", if I'm not mistaken. Okay, so plus 3 standard deviations is equal to 75.5 inches, and that's getting out there. A woman who is 6'3.5", You're getting way out here where there simply aren't too many because the graph is getting very close to this horizontal line here. There aren't too many women that are this tall. This is really getting up there. 3 standard deviations above the mean is significantly above the mean. Mathematically, 65 plus 3 times 3.5 gives us 75.5. Letter B, find the height that is 1 standard deviation below the mean. Okay, using our graph, 1 standard deviation below, 65 minus 3.5, and the height that is 1 standard deviations below the mean is 61.5. So minus 1 standard deviation, the minus meaning below, is equal to 61.5 inches on our graph. Mathematically, it's 65. Take away 1 standard deviation, so 1 times 3.5, and you get 61.5. So there you have it. Very useful because you have a normal distribution. You can find various locations for people rather easily.